This next one here is going to use some geometry along with our coordinate system. So what we're doing is we are graphing a rectangle, and we have two vertices on the x-axis and two vertices on this curve 9 minus x squared. We want to find this maximum area of a rectangle. So let's go ahead and get a picture going. So let's go. So 9 minus x squared, I know that's my parabola. It opens downward, and we've shifted up 9 units, so my vertex is going to be up at positive 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and a little further. And then just to kind of see where my x-intercepts are, I could go ahead and solve 0 equals 9 minus x squared, and that's going to be a plus or minus 3. So let's go ahead with 1, 2, 3, 1, 2, 3. Okay, so all that to get just a visual for my parabola. Something like that. Okay, so 2 coordinates of our rectangle are going to come from the curve, and then 2 coordinates are going to come from the x-axis. So I need to drop that down directly and directly over there to make a nice rectangle. As best I can, drawing freehand here. But imagine that's a nice pretty rectangle, and we are looking to maximize this area. Okay, so side lengths of this rectangle. And something I'm going to do is just quickly kind of think about what are my coordinates here. So like here I have some positive x coordinate, and then the y coordinate is going to come from a 9 minus x squared. Well, over on this left-hand side, I would have that same x value, but it would be the negative form of that. And then for my y value, it's actually exactly the same. It would still be a 9 minus x squared. Because it's like we're plugging in the negative x, but if we square it, it's still just going to be a positive x squared. And then down here, what we would have, on the right-hand side, we'd have x, and then it's on the x-axis, so the y value would be 0. And then over here, we would have some negative x value with some output of 0. So, all that to say, if we're looking for the length across the top here, well, to the right of the y-axis, we have positive x, to the left, we have negative x. So combined as a total distance, that total distance is going to be a 2 times x, because we have 2 distances of x coming through there. And then in terms of the height of the rectangle, well, the height is coming from the output of our function, which is the 9 minus x squared. So if I want to represent area of this rectangle as a function of x, one side length is going to be 2x, the other side length is going to be 9 minus x squared. So we have limitations on what x can be. We're stuck between -3 and +3, and we probably shouldn't have 0, but given those restrictions, we can plug in anything for x, and this will calculate the area of that rectangle for us. Now, we want to maximize that area, so I'm going to take the derivative. I'm going to go ahead with the product rule here. Why not? But we could have multiplied that. Let's multiply it out. It's one step. So if I multiply that out, it would be an 18x minus 2x cubed. So then the derivative will have an 18 minus 6x squared, and we want to see where that is equal to 0. So 6x squared equals 18, which means x squared equals 3. Take the square root of both sides, and we have a plus or minus root 3. And we could just talk about x in terms of a positive value here, since it all kind of goes together. So let's go ahead with saying x is a positive root 3. And then returning to our question, they want to know what is the maximum area of this rectangle. So what I'm going to do is go back to my area function and now plug in this value of x equals root 3. So it's going to be an 18 times root 3 minus 2 and then root 3 cubed. And we could throw that in a calculator or simplify it, and we should get out a 12 root 3, which is about 20.78. And we don't have any units here, so it would just be square units. Okay, so with these, getting a good picture going, I think, I know I'm quite a visual learner. A good picture always helps me out. And then going from there to kind of create our formulas. Okay, the next one. We have a rectangular box with a square base and an open top. So let's get that picture going. All right, there's one side. And let's see, we're going to have, it's going to be square. And we have an open top, so nothing up there. And let's see, square base, so let's call that x by x. And then we're going to have some height as well. Okay, we know the volume is 216. Now with a rectangular box, that's coming from an x times h. So we have this relationship that x squared times h is 216. What should the dimensions of the box be to minimize the surface area? Okay, so we want to make the smallest surface area here. So with that, we're going to need a formula for surface area. And for surface area, it's that we'll have the area of this square base plus 4 of these rectangles that line the sides of the box. So we'll have one of the bases, x times x, plus 4 of those larger rectangles, which will be x times h. Now, we have too many variables here, kind of like we had in our very first example in this section. So what I need to do is that x squared times h equals 216. I'm going to adjust that so that I can express h in terms of x. So 216 divided by x squared. So a function for surface area in terms of x will have an x squared plus 4x, and then instead of h, I'm going to use this 216 over x squared. And then I'll simplify a bit. So 4 times 216 is 864, and then over x. Okay, and actually I'm going to write that as x to the negative 1 because now we're going to take the derivative. So derivative of our surface area function will have 2x minus 864 times x to a negative 2. And we're going to see where is that equal to 0. So 864 over x squared. We're going to go ahead and add that to both sides. Multiply both sides by x squared. Divide by 2. And then take the cube root of both sides, and that should leave us with a 7.56. All right, so our question is, what are the dimensions and what is the surface area? So we know x is 7.56. So that means that h is going to be 216 divided by 7.56 squared, and that's going to be a 3.78. So the box is, our units are inches, so it's going to be 7.56 inches by 7.56 inches by 3.7 inches for a minimum surface area of, and then we'll go to our surface area, which was x squared, so 7.56 squared plus 864 divided by 7.56, and that's going to be 171.46. And this is area in inches squared. So we want to get our units right there. Okay, so there's some geometry examples, and then we're going to move on to some business applications next.